band we meet today. We'd also like to pay our respects to elders, past, present, and emerging. It's 4:45 p.m. You do your final commit for the day. You're ready to switch to your next activity. Phone rings. Please join the bridge. You join the bridge. The incident manager says the system is down. It doesn't make any sense. Your change was a simple feature flag, a title change, an index change. Couldn't have brought down the system. But that no longer matters. All eyes are troubleshooting the last change, whether or not it caused the issue. Ladies and gentlemen, my name is Andrew Goifeld. With me I have Jeremy Vincent, and we are Senior Technical Account Managers working for AWS Enterprise Support. We've seen some of these challenging issues play out. And so today, we've got a two-part presentation focusing on maximizing reliability and deployment safety. In the first part of the presentation, Jeremy is going to walk you through the tools, techniques, processes, and strategies that you can use today for safe deployment practices. And in the second part of the presentation, everything that Jeremy talks about, those APIs, those technologies, we're going to put them in practice in an application demonstration. So let's get started. Jeremy, over to you, sir.
Thanks, Andrew. So what are we going to learn today? We're going to learn how to improve the health awareness of your deployment pipelines. I'm going to do this by adopting pre-deployment safety checks to support your availability and deployment safety goals. We're going to see and learn how we can utilize native AWS APIs to achieve this, all with the intent of minimizing downtime and maximizing the reliability of your workloads. So let's talk a little background first. As this is an advanced session and you're all builders, you're likely across these major categories of failure. You may even have experienced a few of them yourself. I know I have. So today, we're not going to talk about these well-understood categories. They're covered elsewhere in other sessions. Instead, we're going to concentrate on workload health and rare AWS service events. And we're going to explore how these environmental factors affect your deployments. For example, imagine another team runs a business process that affects the performance of the workload that you're trying to deploy to. Or one of those rare AWS service events such as an availability zone impairment impacting on your systems. Just as with sustainability and security, resilience is a shared responsibility between both you and AWS. AWS is responsible for resilience in the cloud, and our customers, you, are responsible for resilience of your workloads in the cloud. Imagine a perfectly healthy RDS database, yet applications that utilize it are exhibiting poor user experience. It turns out this is due to suboptimal queries. This would be on your side or the customer side of the shared responsibility model. You can share this responsibility model with your decision makers to help prioritizing your resilience improvement initiatives. So let's talk about measuring availability. Why do we want to do this? Well, measuring availability is one of the ways we can measure resiliency of our workloads. Availability is measured simply as the ratio of uptime to the total time being measured, which is uptime and downtime. This gives one of those famous availability examples, the infamous 4 nines of availability, 99.99. Now, you're probably asking, all right, so how do we measure uptime and how do we measure downtime? We can use this formula of availability metrics, and I'm going to explain how now. But first, we need to understand some key concepts and the metrics that go with them so that you can focus on improving the availability of your workloads. The first one I'd like to talk about is the time between a failure occurs of your workload and when you detect that failure. This is known as the mean time to detect, or MTTD. Next, we have the time between when a failure occurs of your workload and when you've got it repaired and recovered. This is the mean time to recover, or MTTR. Now, this includes both the time to detect and repair that failure. Imagine you've got an incident. It occurs at 10 a.m. in the morning. Unfortunately, you haven't instrumented your workload, and you don't find out about this until your customers ring you up to complain at 11:15. Now you know where to focus on your area of improvement. That would be on mean time to detect. One thing I want to call out on this slide is that if we reduce the mean time to recovery, there goes the slide. One important thing that I forgot to mention is this thing called mean time between failure, or MTBF, and that is the time between when your workload is a normal operation and when it experiences its failure, and this is an average. Now, as I was saying, if we reduce the mean time to recovery, we increase the mean time between failure, and that improves your availability. So let's talk about deployment safety, which is one of the reasons we're here today. Here you can see a typical continuous deployment pipeline with the 4 common or major phases and the associated deployment safety checks that we typically see our customers implement during these phases. So we have source, build, test, and deploy. Now today, we're not going to talk about these well-known approaches to improve deployments. Again, it's covered elsewhere. Instead, what we want to focus on is increasing friction, and that's to improve deployment safety. You'll primarily want to do this for your production workloads where you're going to value safety over speed. And let's see how. So we're going to do this by implementing what we call pre-deployment safety checks ahead of the actual deploy stage. This is going to be the focus of our session today, and you're going to hear Andrew give us a practical demonstration of the theory that we're going to hear now later in the session. You want your deployment pipelines to monitor or be aware or evaluate your deployment risk. When the deployment risk exceeds your thresholds, you want to be able to prevent automatic deployments into production. This risk threshold is going to be different for different organizations. To mitigate a failure, we first need to detect that it is currently impacting or about to impact our workload. Now, let's talk about how we can make your pipelines health aware. So the first thing we're going to talk about is how you can utilize Amazon CloudWatch to make your pipeline health aware. Here, to detect current impact, we want your pipeline to monitor your workload for high severity aggregate alarms. And this is so that we can understand when an active issue is affecting your workload. The idea then is that we're going to prevent deployments when your workload is in an unhealthy state. And the reason we do that is simple. We don't want to make things worse. So how can we achieve this? We can utilize Amazon CloudWatch composite alarms to detect when your workload is currently unhealthy and prevent deployments to it. So on the slide, we've decided that our commerce platform application latency is important. So we're going to monitor that. And what we've found is that if the latency is over 500 milliseconds, our customers stop ordering from us. So we're going to have an alarm that tracks that. When the latency alarm goes off, it's going to trigger that composite alarm, and we're going to block deployments. This prevents a possible deployment failure, and more importantly, avoids contributing to current impact. Imagine your commerce platform has an incident, it's unhealthy, yet you deploy a configuration change to it. This causes confusion with your incident responders who are now trying to work out what's going on, is this configuration change part of the issue, and that leads to increased recovery time. And as we saw earlier, increased recovery time increases the mean time to recovery, or MTTR, which reduces your availability. So you also have increased reputational risk, and in this case, revenue loss because customers can't order. Now, you're probably thinking, hang on, and you'd be right. It may have been possible that your deployment was safe to deploy, and it may not have been affected by the fact that that workload was unhealthy in terms of latency, and it may not have contributed to the current impact. However, we want to favor deployment safety over velocity. And we're doing this so we can minimize downtime and maximize the reliability of your workloads. We can also use Amazon CloudWatch anomaly detection to detect when your workload is about to become unhealthy. And this all happens prior to any of those existing CloudWatch alarms being triggered. That'll reduce your mean time to detect, improve your availability. So now, we've got our existing CloudWatch latency alarm set to trigger at 500 milliseconds. As you can see, we've got a negative trend, but it hasn't triggered yet. If we add a latency anomaly alarm using CloudWatch anomaly detection, as soon as the latency goes outside the band of expected values, which is based on machine learning and statistical algorithms to understand the baseline of the metric, when the latency goes outside of that expected band, the anomaly alarm triggers, we trigger that composite alarm, hey presto, we block deployments. Again, we're trying to avoid a potential deployment failure as well as avoiding contributing to current impact. For example, imagine we made that configuration change to the workload in the previous example, yet we did it just before the commerce platform became unhealthy and an incident was declared. Now, incident responders are working on how your minor configuration change has caused impact and are busy trying to roll it back. Unfortunately, what they're not doing is troubleshooting the real cause. Again, leads to increased recovery, reputational risk, more revenue loss. Again, it's possible that this was safe to deploy and would have contributed to overall impact, but we want to favor deployment safety over velocity. So let's talk about extending these pre-deployment safety checks with AWS Health API. Life's good. We're monitoring our workload health using CloudWatch, job done. But there's an edge case. What about those rare AWS service events I mentioned at the start of the session? So you want to expand your deployment pipeline to now monitor your environment for high severity events. When they occur, you want to prevent deployments into production. Imagine AWS services. CloudWatch can't monitor them, but we have a service that can. You guessed it, AWS Health API. We can use this to inspect service health for services that we care about. If they have an open issue, we can go ahead and block our deployment. So in this example, we've got a trusty latency alarm and latency anomaly alarm from our previous examples. Both of them are fine and aren't going to get triggered. Now we add monitoring AWS service health for services that our workload depends on. When an open issue is detected, we're going to block the deployment. Again, blocking the deployment prevents possible deployment failure and avoids contributing to overall impact. Again, it's possible that it was safe to deploy and wouldn't have contributed to overall impact, but we want to favor deployment safety over health. So imagine an example where you're deploying an update to your web commerce platform, which is spanning across 2 AZs, but you're doing it during an availability zone impairment in one of those AZs. Now, when you go to replace your EC2 instances, unfortunately you replace the healthy ones in the non-impacted AZ, leaving only the unhealthy instances in the impacted AZ. You guessed it, commerce platform's gone down, incident responders are trying to work out why you've suddenly got service impact, given that it was surviving the service event previous to this with no impact. You have all the reputational risk and revenue loss that we talked about earlier. One thing I want to call out, if you are wanting to monitor AWS Health API, you need to be on a business support, enterprise support on-ramp, or enterprise support plan from AWS. We can also take this a little bit further to monitor organization-wide alarms. For example, monitoring open active incidents using your incident management software. If you're using AWS Systems Manager, Incident Manager, you could do this. So let's talk about how we can achieve this. Here we've got a solution architecture that's based on AWS Code Pipeline. You don't have to use AWS Code Pipeline for anything we said today. The concepts remain the same if you use any third-party tooling for your deployment pipelines. Also, it's a simplified pipeline, so we can focus on the deploy phase. We're going to insert a custom stage into our pipeline for our pre-deployment safety checks. And this is prior to the deploy stage, of course. Our deployment safety checks are implemented using AWS Lambda functions. We've got a function to query CloudWatch to see if there's a composite or anomaly detection alarm that's been triggered, along with the Lambda function to monitor the AWS Health API for any service health impacts. If we detect an open issue or an anomaly alarm, we're going to notify admins using a notification Lambda function. And we're going to use chatbot to talk to them. This is going to do two things. One, it's going to let them know that the deployment didn't proceed, and two, that human intervention is required to potentially resolve the underlying issue or override the safety check. So, you may be wondering, well, what happens if I need to deploy an urgent fix? And that's a great question. Imagine you're in an incident and you need to deploy this fix to recover. Unfortunately, you followed our advice and your deployment pipeline is now blocked. Well, for that and other scenarios, you want to implement a break glass mechanism. And you could do this using the recently released parameterized pipelines feature of AWS Code Pipeline. This allows you to send a flag to it to basically tell those deployment lambdas that they should ignore the check results, return job success, and allow your deployment pipeline to proceed. Now I'd like to hand it over to Andrew, who's going to show us some practical examples.
Thank you, Jeremy. All right, so in order for us to demonstrate these concepts, we really needed to figure out a way to deploy into an unhealthy environment. So how do we do that? Well, for this demonstration, we utilized AWS Fault Injection Service to create a scenario of what it could look like with an AZ power interruption event. What you see on the screen is one of those features in AWS Fault Injection Service that talks to the EC2 auto scaling group to say, hey, when one of my instances is dropped, don't scale back up, instead give me an error. And in doing so, creates that environment where we can really test the resilience and recovery of our workload. So with that background out of the way, let's actually now talk about the pipeline testing. So what you have in front of you is our online commerce platform, right? It's all built on microservices. It's got a shopping cart, it's got a checkout, it's got home button, and every single one of them is a microservice in a containerized deployment. Now, we've built this utilizing our AWS EKS workshop, which is a public and free available workshop from AWS, where you can actually go along and do the same kind of deployment yourself. Specifically, for this demonstration, we utilize the CI/CD part of the workshop using Argo. So that's available for everyone to utilize. So now that we've got our environment, we've got our commerce front end, let's go and deploy the code, right? Before we do though, Jeremy talked about alarms. He talked about composite alarm. You see, the dashboard that you just had in front of you had aggregate alarm, which combined all of the alarms about the health of our application. And in here you see an alarm rule. Now this is a really powerful way to aggregate the health of your workload. But just by having one composite alarm, you can now look at your entire estate of health of the workload. We also heard Jeremy talk about anomaly detection, and in this case, database utilization is a perfect candidate, especially if you suffer from runaway queries. So now all of these bands are set up. You've got a nice big dashboard, right? One other metric I deployed here is auto scaling groups, right, with a number of EC2 instances going up and down, knowing how big my fleet is. Observability is key, and alarms are really, really important for deployment safety. So now you see the observability stack that we've got in this scenario. We're going to start going back to the code that I was talking about earlier. Now, you remember when I started, I said, you're unaware of the situation, right? You're a developer. So in the corner of the screen, you see that the fault injection actually already created that fault, but I'm as a developer, I have no idea. I'm committing code, I'm doing my job, I have no awareness of the entirety of the pipeline or the health of my workload. So now, I do my job, I click commit, and of course, the incident continues. And the key here is, as we mentioned earlier, it was my last change that created it, but it wasn't the thing that caused it. And that's what diverts troubleshooting efforts. What you can see here is that, in my case, the home page render was triggered. There was a problem, right? And that also triggered the composite alarm that we've got instrumented here. That you see the deployment successful, and because the deployment wasn't really listening to the health of the workload. Nothing works. So let's fix this scenario. How do we fix it? Well, what we want to do is inject friction. Jeremy talked about the fact that we want to prioritize safety, deployment safety over speed. We've got these alarms. Let's integrate those alarms into our pipeline. How do we do that? Let's switch over to Lambda code. In here, you see a very simple method. Fetch aggregate alarms. It does what it says on the method. What we're trying to do is go back to the CloudWatch API and say, hey, give me a status of my composite alarm. Now, just by that action alone, by the way, you can put a lot of smarts into your deployment safety, right? Now, in this particular case, I want to emphasize it's a composite alarm, it's part of the API, and that's what you want to aggregate, because you want to make one call that is actually meaningful to your application. So that code we now integrate back up into the actual Lambda function. The Lambda function logic is really simple too, right? All we want to do is go to the API, give me a return, and if the alarm status return is okay, we don't have an incident in progress. It is really that simple. If, however, there's any other return from the CloudWatch API, we want to trigger it as incident is in progress and return to our code pipeline, stop, don't continue. Now, Jeremy did say that this is a pattern here. This is not just about code pipeline. So you can integrate this into your CI/CD pipeline for safety. We've got a meaningful error message here in this logic. The message is returned, and you can integrate that message into your notification areas. You can go back to the chatbots, and it's going to pause the pipeline, allowing you to focus on actually recovery of the workload. So now that you've got this in place, this Lambda function in place, the next thing we're going to do is push this into code pipeline. Now, for this specific demonstration, remember that we haven't yet fixed the problem with the workload. The workload, or our specific web page, is still broken, right? Now, we are going to modify our stage here, and so before we release, we're going to create the check health stage, right? Remember, what we want to do is go out, test whether our workload is healthy, and then proceed if it's okay. The action here is just simple check health. We're going to utilize the AWS Lambda as a provider in code pipeline, and we're going to integrate that into the stage. Here you see the function being chosen, and we're going to click done. and continue from there. So what's really important about this is, as a pattern, you can add another section. Jeremy talked about incidents. Jeremy talked about health API. What you see on the screen is a blog post, and we'll have the URL at the end, so don't worry about trying to capture this. But the pattern is still identical. Call the health API, get a return code. If there is an issue, pause deploy. It really protects that safety of your workloads. You're not troubleshooting the wrong issues. And for this specific talk track, we've also written a very detailed blog post about health-aware pipelines, which you see on GitHub, and you see a link on the AWS blogs website, which we will share shortly. So the detail of this is written up really well. I highly encourage you. But back to our deployment. So now we're going to click save, right? And we're going to test what's going to happen in a situation of stress, right? We've saved our pipeline, we've modified it. Let's now go and release that change and see what happens. As you see, the stage is now applied, right? And we see that the aggregate alarms are still triggered, environment is still unhealthy. So theoretically, deployments should not pass. They cannot. We've got an unhealthy environment. We don't want to proceed at all. As I click release here, you will see it go through the source code, interrogate the source code, and go to that check health phase and fail. And that's good. Remember, we're optimizing for safety. We're optimizing for those workloads that we really care about. We want to be safer on the highly critical workloads. The error message you see is just being put up on the screen there is directly from that Lambda function. Again, that's open to a lot of automation. So now the experiment is over. We've fixed our availability issue. All of our alarms are green. Our website is up. We can browse through it. Things are good. So let's see now what happens when we click deploy on that, when we click release on that pipeline. All the alarms are demonstrating that we should be able to do it. But as a developer, you don't actually look at the alarms. Alarms are meant to be there to help you. You're doing your job. You click release, you click commit. The release process takes care of itself and is optimized for safety. And so what you see now is that, as we expect, it goes from source to checking health, and because our environment is now okay, it's passed all the checks, it proceeds. So that's the demo. Thank you. I'll pass it back to Jeremy. Cheers.
Thanks, Andrew. All right, folks, what have we learned? We learned observability approaches to improve the health awareness of your deployment pipelines. And we did this by adopting pre-deployment safety checks to support your availability and deployment safety goals. We saw and learned how to utilize native AWS APIs to achieve this. So we utilized Amazon CloudWatch composite alarms and anomaly detection to monitor for workload health. And we used AWS Health API to monitor for AWS services for our environmental health. And we talked about expanding this to monitor for open active incidents using AWS Systems Manager, Incident Manager. And we did this all with the intent to minimize downtime and maximize the reliability of your workloads. So I'd invite you to take your cameras out to take a photo of the next slide. If you like the topics and want to know more about what you've heard here today, here's some good resources to get you started. Cool. You can also join AWS Skill Builder, go online, and gain access to over 600 free digital courses, hands-on labs, and role-based games. Andrew and I would like to thank you for joining us today to improve your resiliency. You can come and meet us at the Operational Excellence stand after the session to talk more. Please don't forget to leave without filling the session survey on your mobile app. If you don't have it, you can download the app from the iOS or app stores here and use the second QR code to rate our session COP 408. Thanks.